Welcome to 8.1. This is the law of sines, and it's actually fairly simple to set up. Given a triangle, you basically are going to set up two fractions, any of the two fractions here, as proportions, and I'll explain this in a second here. But what I want to show you down here is there's these types of triangles where you're given sides and angles, and you're missing some pieces. And you don't know whether or not, like on part A here, if little a here is long enough to hit this side or not, okay? And here, it'll only hit once, and in part C, it actually would hit twice if it's swinging from this hinge up here. So because you're missing some pieces of information, you have to understand when you're going to have two answers, one answer, or no answers, like this isn't long enough to make a triangle. And here's one answer here as well. Okay, so you have all these different types of possibilities, and we'll go over those as we get started, but let's just be able to start by setting up the simplest of problems. So let's draw a triangle, and so we're just going to draw a generic triangle. We could draw it to scale, but let's just draw a generic triangle. So A, B, C is a little b, and little c. And little a is 23.7, and alpha here is the a degree, okay, and lambda goes with c, so that's 65 degrees here. This would be beta if we knew beta. Okay, so now what you do is you put like the sine of 52 over 23.7 and set it equal to the other pieces that you know of. We don't know the beta or the b, so we're not going to use that yet. So the sine of 65 over c. And then we just cross multiply with a calculator. Sine of 65 times 23.7 is 21.48, and that equals c times the sine of 52. So we divide off the sine of 52, and that gives us little c. So 21.48 divided by the sine of 52 is 27.26. So that's little c. All right, so that's just little c. Now we got to get b, beta, and b. So again, you would just set those up because we can get beta because we know 52 and 65. 52 plus 65 is 117. Subtract that from 180, and you get 63. So now we know beta is 63 degrees. We can set it up again as the sine of 52 is to 23.7, as the sine of 63 is to little b, and then we can solve for little b. So 23.7 times the sine of 63 gives us 21.12, and that equals little b times the sine of 52. So we'll divide that number by the sine of 52. So divide that over there, and we get little b to be 26.797 or 26.8. So there's all three pieces of the triangle. Okay, moving on. Again, let's just draw a generic triangle here. This will be beta, 25 degrees. Little b is 170. C, A would be alpha, and little a, and c would be lambda, and little c here. 41 degrees is lambda. So let's do the obvious answer, alpha. 180 minus 25 and 41. So 25 and 41 is 66. 180 minus 66 is 114. Okay, so actually alpha is an obtuse angle. And we're just going to start by doing the basic stuff before we go into double angles. All right, so now let's just do our law of sines here. So the sine of 25 over 170 is equal to the sine of 41 over c, and then we cross multiply here. Okay, So we take 170 times the sine of 41, and we get 111.5. And then we have c times the sine of 25. So now we take 111.5 divided by, let's see, the sine of 25. That gives us little c to be 263.8. Okay, so now we have alpha, we have little c, and now we need little a. So alpha, remember, is 114. So the sine of 114 all over little a is equal to the sine of beta, 25, is to 170. So a times the sine of 25 is equal to the sine of 114 times 170, which is 155.3. Now divide off the sine of 25. So divide by the sine of 25, and that gives us 367.5. All right, let's move on from there. Okay, so again, let's draw another triangle. Let's take care of this first, the minutes here. So if we divide them by 60, we get our decimal. So this is 27.6 repeating degrees. And 10 divided by 60 is going to give us 0.16, so 52.17 degrees. All right. All right, so we have two angles and a side. So we're always looking for the side-side angle position. That's the one that is going to give us trouble, but that's not what we have here. All right, so we have alpha is 27 degrees, beta is 52. Okay, so let's go ahead and draw. And alpha is 27.6 degrees, beta is 52.17 degrees, and A is 32.4. Okay, so let's go ahead and rip through these. These two go together, so the sine of 27.6 is to 32.4 as little b. Sine of 52.17 is to little b. All right, so let's go ahead and do the calculations. 32.4 times the sine of 52.17 is 25 point blah, blah, blah. That equals b times the sine of 27.6. So we're going to divide off the sine of 27.6, and that gives us 55.2. So that would be b. Angle C, the measure of angle C, would be 180 minus the other angles, 52.17 minus 27.6. That gives me 100.23. So now we just need little c. So now it's the sine of 100.2 over little c, as the sine of 27.6 is 232.4. Again, 32.4 times the sine of 100.2, and that gives us 31.9 equal to c times the sine of 27.6. So we're going to divide off the sine of 27.6 on the calculator, and c gives us 68.8. Okay, next problem. Again, we just start these, and I just start with A, B, and C. And C goes with gamma. So that's 70.5 degrees. 30 minutes is a half of a minute, or half a degree. Little c is 537, and beta is 50. And 50 divided by 60 is 0.83 repeating. Okay, so we have those degrees. We can get angle A. So the measure of angle A is 180 minus those other angles. 180 minus 70.5 minus 50.8 gives us 58.7. All right, so that's one thing that we need. All right, so we need little a and little b again. So these are the two things that we have, so we'll start with that. Sine of 70.5 is to 537. And we'll do B. Sine of 50.8 is to B. And then when we're done, we can do the sine of 58.7, which is angle A, is to little a. So we'll do this first. So 537 times the sine of 50.8. And that's B times the sine of 70.5 equals 416 point blah, blah, blah. So we're going to divide off the sine of 70.5. And little b is 441.5. Now again, we'll do this part over here. Sine of 70.5 is to 537. As the sine of 58.7 is to little a. So 537 times the sine of 58.7 is 458.8. And we're going to divide off the sine of 70.5. And little a is equal to 486.8. All right. Now we go straight to number 17. To find the distance between points A and B that lie on opposite banks of a river, a surveyor lays off a line segment AC of length 240. So here we just have our picture drawn for us. We do need to make sure we're reading it just so that there's nothing weird. What does it want? It wants the distance from A to B, which is little c there. So what is angle B? What is beta? Well, 180 minus the other angles, 54, 10 minutes is 1 divided by 6 or 0.6. Let's see, 1 divided by 6 is 0.16 repeating. So this is 54.2. And 2 divided by 6 or 20 divided by 60 is 0.3 repeating. So that's 63.3 degrees. All right, so 180 minus 54.2 minus 63.3 gives us angle B to be 62.5. So now there's our two pieces for our ratio. Sine of 62.5 is to 240. And then we need little c, which goes with that angle. Sine of 54.2, is to little c. Okay? So now we just cross multiply. 240 times the sine of 54.2. And that's going to be equal to c times the sine of 62.5. So I'm going to divide that number I just got by the sine of 62.5. And I get the wrong answer. There's no way that's not right. Okay, so 240 times the sine of 54.2 is 194.7 divided by the sine of 62.5. Okay, that's better. So C is 219.5. This is yards. And that's what we wanted. Okay, next one. Number 18. Okay, so 18 is to determine the distance between points A and B. Surveyor chooses a point C that is 375 yards from A. Okay, so we just draw a generic triangle here, A, B, C, and we have 530 for A, that's A to C, and, or excuse me, point C to A is 375. 530 is A. Okay, C to B is 530. Okay, and little c is here. Angle BAC is 49 and 30 minutes is a half of a degree. So it wants A to B. It wants little c again. So what do we know? We know those. So the sine of 49.5 is to 530. As we need that, and we don't have either one of these. So we better get beta. So to get beta, the sine of beta is to 375. Cross multiply. 375 times sine of 49.5 is going to be 285.2 equals 530 times the sine of beta. So divide off the 530, and we get 0.53 blah 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 equals the sine of beta. So to get beta by itself, we got to take the arc sine of that answer. So second sine, second hyphen, gives me beta to be 32.5 degrees. All right, 32.5 degrees. So now we ought to be able to get lambda, or gamma, excuse me, gamma. So 180 minus the 32.5 minus the 49.5 gives me gamma of 98 degrees. Now we can get C. So again, the sine of 49.5 is to 530, as the sine of 98 degrees is to little c. So 530 times 980, or 98, 530 times the sine of 98 gives me 524.8. So 524.8 equals c times the sine of 49. So you should be able to get faster by knowing what to do on your calculator. Divide by the sine of 49.5. So little c is 690.2, and that's the distance between A and B. Okay, next one. Cable car, route. All right, so here we're starting to get into some strange ones. So this is number 19. We have all this information on here, 1.2 miles from here to there, but I want to point out this triangle right here because we're going to have to find some information here. We want the distance from A to P, which we'll call little b, and then we want the height of the mountain. So that's why I drew this right angle here. Okay, so we can't do anything with H until we know something else. We're going to call this H1 and call this hypotenuse 2. There. Okay, so now, what do we know? If this is 65 right here, then this is supplementary with this angle. So that's 115. And then we can get angle P by subtracting those from 180. 180 minus 115 minus 21 equals 44. So that's 44 degrees. And now we have our first part of our ratio. The sine of 44 is to 1.2 as, and again we need to get H sub 2, so that would be the sine of 21 is to H sub 2. So 1.2 times the sine of 21 is 0.430 blah 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 equal to H sub 2 times the sine of 44. So now we have to divide that by the sine of 44, and we get H sub 2 to be 0.62, and this is miles, okay? 0.62 miles. All right, but again, that's not what we want. We want little b. So again, you have to do this again. You're going to have to get that H sub 2 anyway, so we'll go ahead and do this. The sine of 44 is to 1.2, as the sine of 115 is to, this is part A by the way, little b. So 1.2 times the sine of 115 is 1.08 blah 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 equal to b times the sine of 44. So we're going to divide that answer by the sine of 44. And we get b to be 1.6 miles. So that's the answer to part A. Part B is the height of the mountain, which is H sub 1. So I'm going to draw this out here so we have it. B, P, it's 90 degrees. This is H sub 2, or 0.62. This is 65 degrees. Okay, so we want to get H sub 1, which is opposite leg over hypotenuse. That would be the sine of 65. It's the opposite leg over the hypotenuse, 0.62. So to get H sub 1 by itself, we multiply both sides by 0.62. So 0.62 miles times the sine of 65. 0.56 miles. or 0.6, whatever the book says there. Okay, next problem. Number 20. So let's blow this up just a little bit here. Oops. All right, so now you have the length of a shadow down a hill. It wants to know how high the pole is. You have 57 degrees from the horizontal. And then it tells you that to the road, the horizontal is 15 degrees. So if we subtract 57 minus 15, we'll get angle A there. We'll just call these like this. All right, so 57 minus 15 is equal to 42 degrees. All right, so this is 42 degrees. All right, that's good. Now, how do we figure out the other stuff? There's not enough information here yet, okay? The shadow is 75 feet long, so this is 75. Still don't have enough information. So on our picture here, if I make this a right triangle, this 57 degrees, I can figure out what angle B is up here. So take 180 minus 90 is 90, and 90 minus 57 gives me 33 degrees. So 33 degrees is that angle. Now I have enough information. So the sine of 33 is to 75 as, and we're trying to get the height of the pole, the sine of 42 is to the height of the pole. So 75 times the sine of 42 gives me 50 point something, and h times the sine of 33. So we're going to divide that answer by the sine of 33, sorry. And we get the height of the pole is 92.1 feet. And that's the answer. All right, the angles of elevation are given, respectively, 24.1 minute, 24 degrees 1 minute, which is 10 divided by 60 is 0.16, so we say 0.2. So this is 24.2 degrees. And 40 divided by 60 is going to give you 0.6 repeating, or 0.7, so 47.7 degrees. All right, now, points A and B are 8.4 miles apart, and the balloon is between the points in the same vertical plane. Approximate the height of the balloon above the ground. All right, so now what I'll do is, let's blow this up just a little bit. And we're going to drop a point down here, okay? Make it a 90-degree angle. But we ought to get this whole angle here. So 180 minus 47.7 minus the 24.2 gives me 108.1 degrees. Okay. Now, that's not split into two easy pieces here, but we can figure them out since we have this triangle here, and that's 90 degrees. You can take 90 minus 24.2, and that gives you 65.8. And on the other side, the same thing, 90 minus 47.7 will give me 42.3. Okay, so what it wants is the height of the balloon, and we don't know anything else, so we need to get some other figures first. So let's get, we'll call that h sub 1, we'll call this h sub 2 here, okay? Let's get h sub 2, it's a right triangle here, so why can't we just do the sine or something like that, because we have too many variables. You're going to have to use the law of sines to get h sub 2. So that goes with the 47.7 is to h sub 2. And then we have the whole angle is to the whole side there. It's the sine of 108.1 over 8.4. So 8.4 times the sine of 47.7 is 6.21 equal to h sub 2 times the sine of 108.1. So divide that by the sine of 108.1. And we get h sub 2 to be 6.5. Now, we have enough information. Let me just draw this part that we're looking at here. This will be 24.2 This is 6.5, and I want to know h. So that's opposite over hypotenuse is sine. So the sine of 24.2 is equal to the opposite leg over the hypotenuse. So I'm going to multiply 6.5 times the sine of 24.2. And I get the height of the balloon to be 2.7. So 2.7 miles above the ground. That's pretty high. Installing a solar panel. All right, so solar panel is 100 feet or 10 feet in width, which is to be attached to a roof at an angle of 25 degrees. A roof is 25 degrees. Approximate the length D that the brace needs to be for the panel to make an angle of 45 degrees. All right, let's draw this a little bit bigger here. Now, let's go ahead and just make it on here. Okay, I'm going to erase part of the picture here. A little room to work. Okay, so what we have here is a couple different triangles to look at here. If I drop this line straight down here and go across, remember this whole thing, we want it to be 45 degrees, so we'll just hold off on that for a second. We have two angles here. All right, so we ought to be able to figure out a few things. If the whole thing's 45 and this is 25, then that means this is 20 degrees there. Okay, so again, let's draw part of this out here. So that's 20 degrees there. This is 10 feet. It wants to know D. And then we need to find this other degree up here. So we can get that by, you have this the big right triangle here. That's 90, and this is 45. So the other angle has to be 90 minus 45, which would be 45. Okay, so this should be 45 as well. All right, so that's 45. Well, what is this angle here then? So now that we have these two angles, we ought to be able to get this third angle. So 180 minus 45 minus 20 gives me 115. So this is 115 degrees. And there's the two pieces you need. The sine of 115 is 210, as D is to the sine of 20, or the sine of 20 is to D. So you have to do all these calculations to get all the degrees before you start. So 10 times the sine of 20 is 3.4 blah 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 equal to D times the sine of 115. So divide off the sine of 115, and that gives you D, 3.8. So it has to be 3.8 feet. Okay. 23, distance to an airplane. So this is pretty crazy here. Quite a few different triangles to look at here. So I'm going to try to draw this a little bit different. So we have P, Q, draw a right angle here. And this is A. And this is 22 degrees. Okay, and then it gives you a whole bunch of other information. So from a certain point P on the road, the angle of elevation of an airplane is at point A is 57 degrees. So this whole thing is 57. So 57 minus 22 gives me 35. So this is 35 degrees here. And then another point Q, 100 meters up further. So this length here is 100. That angle of elevation is 63. So again, this is 63. And you have parallel lines here. So this is 22 corresponding angles. So 63 minus 22 gives me 41. That's 41 degrees. All right, so now let's draw what we have here. This is 100. Let's point P, this is 35. This is 41, and it's supplementary with this angle. So 180 minus 41 gives me 139. And I can get the third angle, angle A up here, to be 180 minus those. 180 minus 139 minus 35 gives me 6. All right, so this is angle Q. And what it wants is the distance from P to A, which is Q. That's what we want to answer. So we do have two things we need. The sine of 6 degrees is to 100, as the sine of 139 is to Q. And now we just solve. 100 times the sine of 139, 65 point blah, blah, blah. And that's Q times the sine of 6. So we're going to divide by the sine of 6. So Q, distance from P to the airplane, is 627.6 meters. Not very far away. Okay, 24. So a surveyor notes that the direction from point A to point B is south, A, and then west 63 degrees. So you move that 63 degrees to the west. Okay, so that's A to B. And then from A to C, south again, and then west again, 38 degrees. So that angle isn't as far. Okay, so here's what we're looking at here. Distance from A to B is 239. Okay, so there's A and there's B. And the distance from B to C is 374. So if I put this here, that's not going to work. If I put it anywhere here, all of these lines are shorter than 239. So C is going to have to be down here somewhere to make it bigger, like 374. So I'm going to erase that and redraw the whole thing so you understand what it looks like. So we have A to B and A to C, which is way down here, okay? This is 239. B to C is 374. Now, from south, the whole thing there was 63 degrees. And from A to C, this was 38 degrees. So if we take 63 minus 38, that'll give us angle A of 25 degrees. So there's the two things we need. The sine of 25 is to 374. And what is it we're trying to find? The distance from A to C. We want little b. So again, we don't have enough information because we don't know beta. And so we're going to have to find angle C here. Sine of C, or we'll call it lambda, or gamma, gamma, is to 239. So 239 times the sine of 25 is 101.0 blah, blah, blah. And 374 times the sine of gamma. Okay, so now we divide by 374, and that gives us 0.27, and that's the sine of gamma, so we need to take the arc sine of our answer, and gamma is going to be 15.7 degrees. So now we can find beta by subtracting those from 180. 180 minus 15.7 minus 25 gives me 139.3 degrees. And now we can find beta. Sine of 25 is to 374, as the sine of 139.3 is to b. So 374 times the sine of 139.3, and then we'll divide by the sine of 25. And that gives us 577.1 from the distance from A to C. Okay, Force Ranger at an observation point A sights a fire in the direction of north, 27 degrees, 10 minutes. So, and east, so north and then east is 27 and 10 minutes. 1 divided by 6, 27.2 degrees. All right. Another ranger at an observation point B, 6 miles due east of A. So that's the same fire at 52 degrees north, 40 minutes west. So B52 and 40 divided by 60 is 0.7. Okay. Now we can get these angles by subtracting from 90. So 90 minus 27.2 is 62.8, and 90 minus 52.7 is 37.3. And we can get point C if we needed to. All right, so now approximate the distance from each of the observation points to the fire. So we need little b and little a. So let's take 180 minus 37.3 minus 62.8. That gives us 79.9 degrees for angle C. And there's our two values we need. So the sine of 79.9 is to 6 as, we'll find little a now, sine of 62.8 is to little a. So cross multiply, that gives us 5.3, and that's a times the sine of 79.9. So divide by sine of 79.9. And that gives us 5.4 miles. All right, now to get B, so that's A. Sine of 79.9 is to 6, as sine of 37.3 is to little b. So cross multiply again, 6 times sine of 37.3, divided by the sine of 79.9. So little b is 3.7 miles. And those are your two answers. All right, Leaning Tower Pisa. It is 179 feet tall. All right. So let's draw this a little bit better. So this is 179. Draw this a little bit more drastic here. That's theta. And this distance here is called d. And this is 53 degrees. This is 150 feet. Okay, so there's our two numbers we need. Sine of 179 is to 53. Oops, backwards. Sine of 53 is to 179. As A, B, and C. Okay, so let's get angle B. So sine of angle or sine of beta is to 150. So cross multiply. 150 times the sine of 53, and that's 119. And then you're going to divide off the 179. So the sine of beta is 0.6692. So you take the arc sine to get beta. And you get 42 degrees. So this is 42 degrees, which now we can get alpha. So 180 minus 42 minus 53 gives us 85 degrees. All right, well, this is a 90-degree angle that we have here, so that means theta is 5 degrees. That's part A. All right? And now this other part should be really simple. You have a 90-degree angle here for D, and this is 5 degrees here. We know this is 179 for the hypotenuse. So we have opposite leg and hypotenuse, so the sine of 5 degrees is equal to the opposite leg over the hypotenuse. So multiply 179 times the sine of 5. And so D is 15.6 feet. Okay, 27. Let's just go ahead and blow this picture up. And we'll read it, and then we'll move this here. Cathedral is located on a hill, and the top of the spire is viewed from the base of the hill. Angle of elevation is 48. Okay, and the distance is 200 feet from the base. The elevation is 41. Okay, the hill rises at an angle of 32 degrees. So this little angle right here is 32 degrees. So that makes this 16 degrees in that position. but you also can get this angle here. It's supplementary to the 48. Okay, so that should be 132. So let's make this a little smaller, and then we'll redraw what we want here. So we have 200. This is 41 degrees. So we had 48 from 180, and that's 132. Okay, and then we have that information there. Okay, so this is 32 degrees, and this is 16 degrees. So I'm just drawing all these straight lines here. That's 90 degrees. And so now what does it want? Approximate the height of the cathedral. So we want this height right here. Okay, so let's go ahead and figure out this angle. And we get this angle up here. So 180 minus 32 minus 41 is, let's see, 180 minus 130 minus 180 minus 132 minus 41. There we go. 7 degrees. So here we can figure out a few things. Sine of 7 is to 200. And we can get, we'll call this little c, A, C, B. Sine of 132 is to c. So let's figure that out. 200 times the sine of 132 divided by the sine of 7. So this is 1,219.6. Okay. Let's get a little a here. So the sine of 41 is to a, as the sine of 7 is to 200. Okay. So 200 times sine of 41 divided by the sine of 7. And so that is 1076.7 feet. Okay? So now, let's find these other pieces of information. So if that's 32, in this right triangle, we take 90 minus 32 and get this angle, and then supplementary gets us that angle. So 90 minus 32 is 58 degrees, which makes 180 minus 58 degrees should be 122 degrees. So there we have two values. The sine of 122 is to 1076.7, as h is to the sine of 60. And that gives us the height of the cathedral. So cross multiply 1076.7 times the sine of 16, and then we're going to divide by the sine of 122. So the height should be 349.95, so 350 feet. It's a pretty high spire. Okay, and number 28. So a helicopter hovers at an altitude of 1,000 feet above a mountain peak. The mountain peak has an altitude of 5,210 feet. So this is 5,210 feet. Okay. The second taller peak is viewed from both the mountaintop and the helicopter. From the helicopter, the angle of depression is 43 degrees. So since this is 90 degrees, 90 minus 43 gives me 47. Okay. And this is 90, so 90 minus 18 gives me 72. And we can get the last angle by 180 minus 47 minus 72 gives us 61. And there's our two values that go together. Sine of 61 is to 1,000. And we're going to try to get the different values around it. So we probably want to get, if we do A, B, C, probably want to get little b here. So let's do that. The sine of 47 is to little b here. From peak to peak, I guess that's the first one. Part A is what's that distance. So that's what we're doing here. So let's calculate that out. 1,000 times the sine of 47 divided by the sine of 61. So little b is 836.2. 836.2. All right. So now we want this little piece of information right here, that height. So let me draw this out here. To get the height, this is 18 and this is 836.2. Well, opposite and hypotenuse is the sine. So the sine of 18 degrees is equal to the opposite leg over the hypotenuse. So take 836.2 times the sine of 18. And that gives you 258.4 feet. And that's the approximate height of the taller peak above the other peak. But now you need to add 5,210 feet to that. And that gives you 5,468.4 feet. That's the altitude of the taller peak.